You're ready? Hello, my name is Udovich, and today I will be teaching you about what a C++ pointer is. So at a high level, pointers in C++ are objects in memory that give us control over previously created objects in memory. This is really helpful for more complex data structures as it allows us to interact with objects without redefining them and lets us move around memory more fluidly. So first, let's go over what the memory diagram is in C++ and how it works. So as we can see here, we have three different objects. We have a string, an integer, and a class comprised of a string and an integer. And as you might be familiar with, each of these objects has its own location in memory, its own home in memory. Now, memory homes aren't always continuous. They vary in size of the object, but it's important to understand that we can access the object that's referenced by the original variable name by going to that memory address for the object. So next we have references in C++. So references are important to understand because they're basically an alias or another variable name that can interact with that object in memory that the original variable name established, and they allow us to interact with that object at that memory address. And they're important to understand for pointers. So as we can see here, we have height is equal to 72, and then we declare a reference variable by saying the data type name with an ampersand, the reference type variable name, and then we set it equal to that original variable name. And what references are doing is they're just pointing to that original memory address that height had. So we can kind of think of it as we have ref, and then it goes to height, and then it goes to the object in the memory location. And what this lets us do is if we say something like ++ ref, and then we were to print out height, we can see that ref is interacting with the object stored at height's memory location. And what's good to see here is if we print out both the ampersand height and ampersand ref, this gives us the memory location of height and ref, and we can see that they're both the same. So ref is just an alias name for height. Now getting into pointers, pointers are a lot like references in that they point to a memory location they can interact with that object, except we have a bit more control over pointers as we can use reassignment and we can use arithmetic operators on them. So as we can see in this first line of code, we have our integer height, and then we declare a pointer h to the memory address of height. We use that ampersand as we did in the last slide. So we say data type asterisk pointer name, and that creates a pointer. And then if we print out the pointer, it has the same memory address as height did from the last slide. So we can see pointer h is going to that memory address that the object in height is stored at. If we say print out asterisk pointer, that's called dereferencing the pointer, which gives us the object at that memory location. We can see it's 72, so the pointer is equal to the object at 72, or it's pointing to that object. If we say dereference pointer h +1, and then we print out height, then we have 73. As we kind of solve with references too, pointers work the same way that we can interact with that object in memory directly. So we can also reassign pointers. So right here, we declare a new pointer. We set it to null pointer. So null pointer is a special location in memory, and it's basically saying that, hey, there's nothing here, and it's not pointing to any object in memory. And as we can see, if we take pointer h and we set it equal to null pointer, and then we print out the memory address of pointer h, we can now say it's all zeros, which is the memory address of null pointer, and it's not 72. It's not 72's memory address as it was earlier, so we can see that we reassigned the pointer. So to wrap up, a review of pointers versus references. So references, as we said before, are just sort of alias variable names that go to that same memory location and can interact with an object. Pointers can do pretty much the same thing, except we can reassign them to different objects in memory, and we can also use arithmetic operators on them. So what this means is if we have sort of like continuous memory or objects next to each other, we could kind of move between them with the ++ and the -. We can also set pointers to empty with that null pointer value we talked about. And since pointers are objects, we can also have a pointer to a pointer, giving us a greater degree of control. Whereas I mentioned before, references can only have one reference for their whole lifetime, but they can interact with objects the same way. So thank you very much. This was my presentation on pointers, and I hope you'll have as much fun using them in future projects as I do.